Hello, David here, and welcome to this tutorial, where you will learn how to control the process modeling flow with statements in Visual Components. When following any tutorial, check the lesson in the Visual Components Academy, and if the Download Files option appears, you can download the example files. Products in simulation move based on their flow, their value-adding flow. There can be multiple different flows in production, but for a product to move from the first process to the second process, there are several requirements that need to be fulfilled. The first thing is that there is a transport link creating a path from one process to the next. The second thing is that the path has an implementer. In this example, a human operator is assigned to this transport link. And in addition to that, the first process needs to push or feed the product to the second process, which needs to pull or knead the product. And also, the kneading process may filter the products that it is accepting. So it needs to accept the same product that is about to come to the process. And these pushing and pulling events depend on the statements used in a process. So first, to transport the product out from a process, then transport it in to the next process, and then maybe process it and again transport it out to the next process. We are in the Process tab, and in this example layout, we have 2 flow groups and 5 processes. And opening the flow editor from the ribbon above, the flow group or flow of the first group, offline flow, will go from feeder to offline process to sync, while the second flow or flow group does not yet have a flow. But if we press play to run the simulation, the products will move from one process to the next, and there are a couple of seconds of delay in the process. So what is the difference between these flows? The difference is that in the flow of this offline flow, the products will move from one process to another. So for example, this offline process is expecting a product from the previous process, and then it is pushing or feeding the product to the next process. While in the flow below, this inline process is expecting the product to just appear from a container. And in this case, the products are in a conveyor's container. And in the same way, when we push the product out, we just drop the product into the container this process is connected to. And in this case, it is a conveyor, and it just moves forward. So we don't actually need a flow in this case, if the product stays in any container, and it moves from one container to another. And resetting the simulation, what happens then in processes? If we first check, for example, this offline process. When the flow editor is active, to open the process executor panel, we right-click on the process label. It consists of 3 statements: transport in and transport out, and a delay in between. This transport in and transport out are the basic statements that are used to push or pull products in production. And if we run the simulation, we can see that the transport in is active. We have a small delay, and then we briefly visit the transport out statement. And these transport in and transport out statements have, of course, properties. So if we select the transport in the statement properties panel over on the right, it has a mode that we will discuss later. It has a source, which is from previous process or from component container, like we mentioned earlier. Then it has product position frame, resource position frame, and to what product variable name the product is saved when it arrives to a process. And then it has a product filter. In transport out, we have less parameters because we are just trying to get rid of the product. But also here we have the mode and we have the destination, which is in this case to next process. If we open this inline flow process, it has the same statements. But in transport in, we expect the product to arrive from source from component container. And in transport out, we push the product with destination to component container. So in this case, in the offline process, the product does not start its transport from the previous process feeder unless the transport in is active from this offline process. And also, in the previous process feeder, the transport out is active with destination to next process. So we are pushing a product and we are pulling a product. We have a transport link between them and the product is matching. So this process is expecting a filtered product. But in this case, there are no product filters yet. So when we have a push, we have a means of travel. We have a flow, we have a pull, and the product matches what this offline process expects to arrive, and then the product moves. And opening the inline process, in this case, we just expect the product to appear in the process by any means. And when it appears, we run the next statement, and then we push the product that appears back to container. And then it's the container's task, or in this case, the conveyor's task, what to do with the product. And that is the reason why this is as it is, and it does not require a flow. And resetting the simulation, if we now change the behavior of the inline flow, so for example, we add an actual flow there. So we click and drag the inline process to the inline flow, and then the inline sync, and we create a transport link between them. We can also add processes to the flow by left-clicking on one label and then the other, and the transport link is automatically created. And then of course for the inline process, if we don't change the transport out from destination to component container to destination to next process, and we run the simulation, nothing changes. Even though we have processes and a link, it still blindly puts the product to a container, which in most cases is a type of conveyor. But if we then reset the simulation and change the transport out to destination to next process, and of course in the inline sync process we need to match it, so for the transport in, the source of our product is changed from component container to from previous process. And running the simulation, now the behavior changes. So now the product arrives to the process and there needs to be a need in the next process. So we can see that there are no additional products moving between the processes until there is a need in the next process. So the behavior has changed. So we need to have feed, we need to have need, we need to have flow, we need to have a transport link. And in this case, the transport link's type is conveyor transport. So even now, when the behavior changes, the product is still on a conveyor. And if we reset the simulation and continue changing the flow, for example, we select the process step handle of inline sync in the flow and delete it and delete the transport link, and we click and drag the offline process and the sync into the flow of this inline flow product, and then selecting the node of the inline process, create a transport link to the offline process and then to the sync. Again, we can use the automatic method to add processes to the flow by selecting the node of the inline process and then the labels of the offline process and the sync. And we already changed the transport out of the inline process to destination to next process, which in this case, after the inline process, is now the offline process. And running the simulation, the offline process begins to pull new products to this process based on the timestamp of when the feed has arrived. So now it will take one product from the feeder process and one from the inline process, and so on. So now the product partially shares the same flow with the offline flow. And now we have two flows that partially go through the same processes. And resetting and running the simulation, because the products now go to the same process, we can filter what is and is not allowed into this process using the product filter feature that we mentioned earlier. And opening the offline process, this product filter parameter or property is common to all types of transport statements. And selecting the transport in statement, we can see that there is no filter, or actually there is a product type filter, but it is not yet active. And the product filter we will test while the simulation is running. So if we now enable it, and for example, set the accepted flow groups to inline flow, now only the products from the inline flow can enter this process, even when a product is available from the offline flow. And if we add the offline flow and remove the inline flow, now only products from the offline flow will arrive. So the filter in transport, or generally in flow statements, affects what the process is accepting and when. And this is an extremely good feature when we begin to study the rest of the flow related statements. So if we change this back to inline flow and remove the offline flow, now the big cylinder is the only product that is accepted into the process. So now we have a flow which currently accepts only the product from the inline flow. And resetting the simulation, if we modify this offline process, selecting the transport in statement, we see that we transport in with source from previous process, a product that we save into product variable name product in, which is also common in all of the flow statements. And we filter with accepted flow groups set to allow only members of the inline flow group into this process. But what if we want to attach, for example, the cylinder from the feeder process into this component from the inline flow? In order to do that, first of course we need to transport in both of the products. Then we need to attach the child to a parent, and then we will transport out the parent. And in processes like this, normally changing the product variables is a good idea, so that we know which product is which. For example, in this inline flow, we first transport in the product. So we will edit product variable name to cylinder and press enter. And selecting the transport out statement, we will also edit product variable name to the same cylinder. But in addition to this transport in, we would also like to transport in the second product. So then, with the first transport in statement selected, as we want to add another statement below it, we select statements from the upper right corner of the panel, and from process flow statements, we select to add a transport in statement. Again, the source will be from previous process, because it is arriving from this offline flow. And what do we call it? We will set the product variable name to can. And do we want to filter the products? Yes, we do. So we click to add a product type filter so that by accident we don't get a second cylinder product from the inline flow. We want to have a product from the offline flow, so we set the accepted flow groups to be the offline flow. Or to be exact, we could set the accepted product types to be the VC can. So now if we run the simulation, first the cylinder arrives, and then we pull the can. But then, after a delay, only the cylinder leaves, and we have a stray product in the process. And resetting the simulation, and with the second transport in, product as can statement selected, after we transport in the can, we could say attach. So from statements, under process statements, we select to add an attach statement, which assumes we will specify a parent, which we set to cylinder, and a child, which is the can. And now running the simulation, the cylinder arrives, then the can. They are attached, there is a 2-second delay, and then they leave together. And as a reminder, the flow of this can stops in this offline process, and it will never arrive to the sync process because it is now part of the flow of this cylinder. And resetting the simulation, there is a process statement similar to attach, a detach statement to detach a product from the parent component. But what if we want to attach more than one can to the cylinder? And instead of transporting in an individual product, we could transport in a pattern of products. So then selecting the second transport in, product as can statement, and deleting it, we then select the remaining transport in, and from statements, under process flow statements, we select transport pattern in. And in this statement, we have some more parameters, for example, what kind of pattern count we would like to transport in. We will set the X and Y values to 1, and we would like to transport in 3 products on the Z axis, and with a pattern step of 150 mm in the Z direction. And the first offset, where the first product arrives, is already 100 mm up from the frame where the products arrive. And in the same way, we will add a product filter here. So adding a product type filter and accepted product types VC can will be the only accepted product created from this feeder process. Then all of the arriving products are saved to this product variable name called can, that in the next attach statement we attach to a cylinder. And if we run the simulation, the cylinder arrives, and then the first can arrives, then the second, and the third. They are attached to the cylinder, there is a small delay, and the whole stack is transported out. And resetting the simulation, in addition to the standard transport in, transport out, transport pattern in, and the attach and detach statements we may use in some of the processes, there is a second type of statement for transporting individual products in called start transport in. And what is the difference? A transport in statement, when it is triggered and running the simulation, the execution will stop at that statement until the product has arrived, and then we save the product variable to a variable called cylinder. But if we want to transport in this base and this stack of products at the same time, we could start the transportation of the cylinder in first and then wait for the 3 products to arrive. And after that statement, we just check to make sure that the cylinder has arrived. And resetting the simulation, So in that case, with the first transport in statement selected, we go to statements and from process flow statements, replace this transport in with a start transport in. Then remove the first transport in statement, and here again we will add a product filter with a product type filter and set accepted flow groups to be the inline flow. And here you can see that we don't have a source, so we cannot start transport in from component container. So it is always by default from previous process. And for the product variable name, we will use the same cylinder so that the following attach and transport out statements will work. In addition to the start transport in, we need to wait and check that the product actually arrives at some point in the process, and the logical place is before the attach statement. So then, selecting the transport pattern in statement from statements and in the process flow statements with start transport in and start transport out, we also need to wait for the transport to complete. So we will add a wait transport statement which blocks the execution. And what product variable name do we need to wait for? The cylinder. So what is the difference now in the flow? If we run the simulation, we can see that the products start to come in at the same time. So we are creating the stack at the same time as the cylinder arrives. So what happens in the process is that we start to transport in and transport the pattern in at the same time. And then we just make sure that the cylinder has arrived. And then we attach delay and we transport the cylinder out. And resetting the simulation, the same mechanism works of course with the transport out. And selecting the transport out statement, instead of this transport out cylinder, from statements we could say start transport out. And the product variable name again is cylinder. We then delete the original transport out, and of course again we need to wait for the product to leave. So we will copy the wait transport statement above and selecting the start transport out statement, paste it to the end of the list. But what is the point of this? It's that when the product leaves, then we could perform some processes. So we will drag the start transport out statement above the delay statement so the delay occurs after that. So the product leaves for 2 seconds, then we check if the product has actually left. So practically, if there is no need, it could be that the product is still here. So in that case, we wait at the wait transport cylinder statement, and after 2 seconds, we start to bring in the new cylinders. So running the simulation, we create the stack, and we transport in the cylinder at the same time. When both arrive, the stack leaves, but we are still waiting for a 2-second delay. We don't start the process from the beginning, only after 2 seconds have passed, and we make sure that this cylinder has left the process, and indeed the cylinder does leave. And now we start to transport in the cylinder and the stack of 3 at the same time. And resetting the simulation, as an example, in machinery, there could be, for example, a door opening or closing, while the next product starts to enter a process. Or we could say, start transport out of a product from a machine. And then there is some machine process that needs to be done anyway, but it is done parallel to the transportation event. So we may have a transport out. We may have a machine process that takes 10 seconds. Then we just check that the product has actually left, and then the machine can start its cycle from the beginning. To show the next flow-related statements, let's introduce a new flow group. So from the product type editor on the left, click the green plus icon and select Add Flow Group. And double-clicking on the name, rename it to Return Flow and press Enter. And we will copy the VC cylinder component above into this flow and rename it to Return. And for visualization, under its properties over on the right, change the cylinder height, the product's height, to 300 mm. And now we have a third flow in our system, and selecting the return flow, we will define that the flow goes from offline process to inline sync. And if we now go to this offline process, we start to transport in cylinders. We create 3 cans on top of it, we wait for the cylinder to arrive, we attach the cans to a cylinder, we start to transport out the cylinder, and we expect it to leave. So it follows the cylinder's flow from the inline flow. But what if we want to change the flow after the process to this new flow, return flow, for example, so that it returns to this inline sync and then it may continue its flow there. Then after the attach statement, so that we know we have the cylinder and cans attached there, we could use from statements under process statements change type. So in this case, we can define which product variable name to use, in this case cylinder. And for new type, which product type, we select the return type. So from this point forward, it will use the flow of this return flow. So from this offline process to inline sync. And running the simulation, the flow is as it was. There are some parallel events. We create the stack, but when the stack is done, we change the product to be the high product. And it uses the flow of the return flow, and it goes to the inline sync and is deleted after 2 seconds. And now we can see that the parent components are still there, and this kind of change type can be used, for example, to reroute products. For example, if there is a defect in a process, some of the products may go into the inline sync process instead of the sync process. Or we could split a long production flow into segments or parts with the change type. And also for simplification purposes, if there is a complex structure. For example, that you have assembled or used the transport pattern in to add multiple products in there. And resetting the simulation, we could simplify the model in simulation with a change type by checking delete attached, so we won't have the attached products included after the change type. And running the simulation, the products will arrive, but the attached cylinder after the change type will disappear. So now we have a simplified model that continues the production. And resetting the simulation, so change type of course changes the appearance of the product, so it can also be used to change just the appearance and keep the flow. But also if the new product type that we change type to has its own flow, then it starts to use the flow for that product type. The same effect can be achieved, and of course many more things, with the create and remove statements. So instead of the change type, which we will delete, for example, after the attach statement, which we will select, we could add remove and create. And selecting the remove statement, we could remove the whole cylinder by adding product variable name cylinder. And selecting the create statement, set product type to return to create the new return component, and save the product into product variable name return part. And now of course we need to update what we transport out. because we deleted the cylinder. Now we have the new return part. So then, selecting the Start Transport Out statement, we need to start transporting out the return part by updating the product variable name from cylinder to return part. And we may need to wait and check that it has left. So we also update the wait transport statement product variable name from cylinder to return part. So now running the simulation, the effect is in a sense the same thing as with the change type. But of course, the create statement could be used to model, for example, this feeder process, instead of using the feeder behavior modeled in that component. And because the newly created product has its own flow, that flow is used. In addition to change type and, for example, remove and create a product type, we can manipulate the flow with the flow sequence statements. So we could get a flow step, use find flow step to find, for example, some implementation or some process from that flow, and then use set next flow step to set it to that product. And then the product's next target in the flow is the step that we set it to be. And in that way, also we could, for example, force some of the products to not go to this sink. Instead, go to this inline sink, which we achieved with the remove and create and change type statements. So that is just a secondary option if more complex flow manipulation is needed. There is a separate tutorial on using these flow statement types, which we will link to in the video description. And selecting statements, there is also a common property for many of the process flow statements, such as transport in, transport out, and start transport in and start transport out. And selecting the start transport in statement as an example, there is a secondary mode that is not just for transporting in an individual product, but for processing an assembly that has been defined in a product type editor. And these statements can be used to partially or completely assemble or disassemble the assembly. And there are separate tutorials on assemblies and related statements, which we will link to in the video description. And this concludes the lesson. Thank you for watching.